All right, so, all right, let's go ahead and get started. Let me get back over to my other screen here. So today, the presentation is titled Redis Data Structures, including PubSub and Redis Streams, because I wanted to go over a few of the beyond caching scenarios as well, not just going to PubSub and Redis Streams, primarily to give all of you a well-rounded kind of overview of some of the things you can do with Redis beyond the cache. And as you guys all know, maybe some of you didn't, that Redis is very popular among developers and very well loved. In fact, for the past 3 years in a row, on Stack Overflow, they run a very large survey, and Redis has been listed as or nominated as the most loved database for 3 years in a row. And why is that? Well, some of the top differentiators are that it's super fast. It's very simple. It's got a lot of different data structures. Each one of them have their own commands and are very simple. It's almost, not quite, but almost like having 10 different databases in one. And it's extensible. We've got these modules. So, I'm not going to go into this detail, but obviously it's very fast and it beats out a lot of the competition. Why? Well, it's primarily in database. It's very stable. It's very simple. And it does what it does best. What I like about Redis is that you may not recognize this image, but this is an image from the movie 2001: A Space Odyssey, where Commander Bowman is looking into the monolith. It's this like 1 meter by 3 meters by 9 meters black like monolith, and it's in space, and it just looks black. But when he gets really close up to it, he looks inside of it, and he says, "Oh my God, it's full of stars." Well, Redis to me is sort of like that. It's a simple thing. But hold on a second here. I got a comment or something that popped up. It's a very simple thing, but it's very full of these different data structures that are very, very powerful, and that makes it very special. So what are those data structures? Well, you've got strings, which is what people mostly use when they're doing a cache. Very simple. It's a key and then a string value. So you look up the key and it returns the string. Very simple. Then it's got all these other data structures from bitmaps, bit fields, hashes, lists, sets, sorted sets, geospatial indexes, hyperlog streams, and PubSub, which isn't really a data structure, but it's important to list that because it in some ways behaves a little bit like one, because you can set up channels and then subscribe to them. So a lot of different data structures. Each one of them has their strengths, and you should know about them because they can help you do things that you didn't know was possible. All right, and then there's a bunch of modules too. So if you're going to be at the hackathon, then there's modules you can use that we're encouraging you to use, like the Redis search module, Redis time series. And Redis search is kind of like Elasticsearch. So if you want that kind of capability, but you want it in memory and fast, then you can use Redis search. Redis time series is kind of like maybe like InfluxDB, and so you're going to get that sequence and the compaction of historical data to be so it makes your searches very fast and summaries and all that. Redis JSON is kind of like MongoDB in that you can store documents and it automatically indexes some of them for you and gives you a lot of that additional benefit of storing a JSON document in memory. And Redis Bloom is a Bloom filter. If you're familiar with hyperlog, which you might not be, but if you are, it gives you the ability to have a very compact yes or no answer to your questions. Like, does this data exist in my larger data set somewhere else? And it'll give you very quickly a yes or no. So you can store large amounts of yes or no's in memory. And so a hyperlog doesn't store yes or no's, it stores total amounts. So yeah, it's very, very powerful, even if it's not 100% accurate. Sometimes you don't need that, but you need the power. Redis Graph is a graph database, maybe like a Neo4j. It gives you that ability to have a social graph or other graph of nodes in memory, just like you would with like a Neo4j. It uses the same cipher commands. And Redis AI is a module that lets you store your TensorFlow or your PyTorch model in Redis in memory. So basically, it gives you a way to serve up your models very fast. And there's more too. You can go check out that URL here. You can search out on Google for Redis modules, but if you go to redislabs.com/community/Redis modules hubs, you'll see the complete list there. Okay, so yeah, so let's get into this real quick. First of all, when you're using Redis, a lot of people know how to use it as a cache. A lot of people also know to use it to store your sessions. You know, this isn't going to be something exciting for the hackathon, but I just want to highlight this because some people still don't know that Redis is the best place to store your user sessions. So when someone logs into your website, store their user session in Redis. It's super fast. It helps you scale out. It takes the load off your SQL database or whatever other databases you're using. Put that in Redis. And so it's very simple. You can use hset command to save your session variables. You can specify multiple field values, so you don't have to just have a string. You can have field value, field value, field value. You can retrieve those field values out. You can increment fields without having to pull the whole data set out and then return it, or even pull out one field and return it. You can just simply tell it which field you want to increment. And you can set an expiration so that Redis will automatically delete the key after 20 minutes or however long you want to set your user sessions. And expire is great. You can use that for lots of different keys and have Redis do the work of automatically expiring for you. All right, so I just want to give you that one. Super powerful. You should use that for every web app you're trying to scale. Here's an example of how you might use that code. hset user session :1 is the key. Maybe you don't know this, but separating your sort of like it's almost like a table name or a collection name is user session, and then :1 would be like the unique value for that collection. But we put them into one key so that it's very fast to look up. We don't have the overhead of having collections and tables and things like that. But this way you have your keys organized in a way that helps you understand what you've got. And then there's the field values. The user ID is the field, and you got the value there, and you got a bunch of them. So you can then get them out. You can increment a field. You can delete the field. You can expire the whole key in the future, or you can just delete the key. So pretty powerful. There's other commands, of course. So go check out the Redis hashes data structure and use it for your user session store. All right. So let's talk about queues. Queues are awesome. So powerful. It's so simple. This is actually one of the very first data structures that Salvatore created. Basically, what you've got with the queues is you've got let's say you've got a lot of items that you want to work with. It could be the original problem was you simply had a bunch of data coming in, and it was metrics that were coming in, and you wanted to put them into a MySQL database, but the MySQL database could not handle the speed. You wanted to reach up to, I think, like roughly 100,000 rows per second, and MySQL couldn't handle that. So what he found out is that it could handle if he were to do them in batches. So let's say batches of 1,000 at a time, and he can do 100 of those per second. So, but he needed somewhere to store the data. So he created this list data structure, which is really simple. It's just a key, and you're going to do like an L push to that key over and over and over again to add your items, and then you can do or an R push if you want to put them to the other side, more of a virtual concept of left and right. But then you can do like an R pop L push to move them to another queue, or just pop them, R pop to pop them off of the queue, and you can pop like 1,000 at a time and dump them into MySQL. So very, very powerful. There's lots of client libraries now that help you manage all of this. And in fact, there's even a module that Salvatore is working on called DiskQ, I think, or Disk, that will help with some of this stuff. But anyway, very powerful concept. And so here's how it would look. If you're going to use this, you can use these commands. By the way, these are all just command line commands. It's not in a particular language. So you can copy and paste these commands, or just type these commands right into your command line, and they should work just as is. And so here's an example of where we're going to push to a queue called Q:1, a task called task1, and then we're going to dump them all in there. So you should see task1 moving to the right as more tasks get added to the queue. And if you want, you can do an R push. I don't know why you do this, but I want to show you that you can do this. Maybe you wanted to prioritize something, and you can do R push. It pushes it to the front of the line in this case, according to how I'm looking at it. Now, once you do that, what do? Well, you might want to move them to another queue. So you might do R pop L push. That's going to pop from the right side of the first queue, and called Q1, Q:1, and it's going to push to the left side of Q:2, and it does that sort of in like a transaction, so that you know that when the response comes back to you that it has completed its task, and task 4 is now over on Q2. So it's a very server-side function. So very, very powerful, very fast. And of course, you can use rpop to pop off the right side, and you just simply take that value and use it somewhere. Okay, so that's a very powerful one. Leaderboards. Let's say that you're trying to keep track of error messages that go to your API. So every time an API call is made to your server and you run into an error message, you can throw that at a sorted set. This is something that Netflix has done. I think they still do it. And they do it for their APIs all around the world. They have over 1 billion API calls per second, I think billions per second. And they take all the error messages and they throw them at a Redis sorted set. And that what happens there is the key, in this case, is your leaderboard name. And then you would have the value, which is going to be unique. So that's the error message that's coming in. And every time that error message comes in again, you increment. So you end up with a leaderboard where the top error messages are floating to the top very fast. This allows you to see if anything new is happening right away. You can see something popping to the top, and you can address it right away. So how would you do that? Well, like I said, this is, oh, by the way, I also want to mention this is also something you can do for leaderboard in a game. So you might have many users playing a game. Think about it like you've got millions of simultaneous users, and their scores are all changing at the same time. Like, how on earth would you do that in any other database? I don't even think anything could possibly keep up. So, but you can do that in Redis. So you can, imagine playing like a multi-level, or sorry, multiplayer, massively online multiplayer game, role-playing game, and you've got, you want to know like in real time what the scores are. You can use zadd to add user and score. You can do z increment by to update a score, and then you can pull them out using z reverse range. And this is something that you would do for not only your top scores, the first, second, third, fourth, etc. player, but let's say you're like player number 10,000 something, and you want to know who's ahead of you and who's behind you. Well, Redis can go and find player 10,000 very quickly and pull out the top, the players just above and below, very, very fast. So very, very efficient way to handle a large, massively online game. So specifically, here's an example. You can just use zadd game:1 and then the score and then the player ID. And so in this case, you got player ID A and player ID B. And you can just see them, they're popping onto the leaderboard. And then you can do an increment by for player ID C by 20, and it pops them up there. And you pull them out by saying z reverse range and then the game ID, which is your leaderboard, and then the range or the actual you can actually pass in the game the user ID. So let's go on to the next one. Let's say you're searching within a geographical area. Maybe you're building a ride-sharing app or something where you want to see what's nearby and you want it to be fast. So it could be something that's changing often. Maybe you've got like a car that's coming to you to give you a ride, and you want to know like where are the cars on your phone. So you're using Lyft or Uber or S-Ride or one of these. You want to know what's moving around you. Redis is going to be awesome for that because it's so fast. And so you use Geospatial Index for that. You use GeoAdd to add a point into the map. GeoDist to find the distance between 2 points. GeoRadius to find all points within a radius. You can add different areas by squares, so you can break them up into smaller squares, and you can find all within like some sort of, if you have a polygon type shape, you can break it up into squares and then look in that shape, in those squares for what's nearby. And so here's an example of it's very simple. This is built on top of the sorted set data structure. So you can actually use sorted set commands with this, but here are the commands that they added. So GeoAdd adds in adds a point called SFO onto the map using this latitude and longitude, and then it converts it in the back end to a geohash, which is what it actually uses to search. And so here I'm adding 3-4 locations, and then I'm finding what are all of the locations near reInvent. Actually, this is I just remember this is my example I gave at reInvent. So yeah, you're going to do georadius by member, and you pass in the reInvent member to the locations key, and it's going to find all of the points that are within 15 miles. Then you can change it to kilometers or whatever you want. Now, let's get into PubSub. Now, PubSub is very powerful, very popular. If you want to have real-time information in your app when something changes in the server, this is really good. So this is very, very popular capability that you may already have used, or if you haven't, you probably will someday. Let's say you need to publish instant event information or notifications to distributed applications. So that could be an application from a server sharing data out to mobile apps, or to another microservice, or it could be some workflow that needs to be notified to start, that kind of thing. And or like the example I used before was you've got a shared collaborative calendar, and somebody blocks off some time on your schedule. Well, you need to know that they've just added that meeting to your schedule. So if you have your calendar open and you're trying to plan something, you need to know. So it's going to pop up on your calendar and see that, Drew over here just scheduled a meeting with me. So that kind of thing. And, this is great concept that's being used. Is very popular in like React.js or Angular or, whatever client libraries out there you're using. And so the consumers, the consumer app, so whatever it is on the consumer side, is subscribing to the topic, and it will receive the notification independently from other clients. And this scales really well. You basically just use the subscribe from the client, and then you use publish, and put that in here, but use publish to actually publish the notification to a topic, and then all of the clients that are subscribed to that topic will receive it. So this works great. Here's some examples of how you might do this. So I wanted to point out one of the flaws in this concept, though. So just follow along with me here. If you want to set this up, what you do is you open up 4 tabs in your terminal. So you got Redis running on your somewhere. It could most likely on your laptop, but it could be in the cloud somewhere. And so start your service, Redis-server. Do a flush all or something, just so you know it's clean, especially if you're doing this in your laptop and you just have a new Redis database. Just get rid of everything. And then, which I have to do all the time because I forget to do it sometimes in my demos. But then you have 3 other windows. The first one on the right is going to be your publisher. So you're going to publish channel 1, publish to channel 1, high 1, okay? Now, if I then, after that, go to my subscribers, I've got subscriber 1 and subscriber 2, and I say subscribe to channel 1, they're not going to get this information. So, oh gosh, I just noticed I'm missing something here. Oh, no, I'm not. Okay. So, so if I now subscribe to channel 1 from subscriber 1 and subscriber 2, they're not going to get it. They're not going to get high 1. So they missed that information. That's kind of the downfall, is that there's no way to go back and capture it. Now, let's say I do a publish channel 1, hello 2. Both subscriber 1 and subscriber 2 are going to receive that information. Now, I'm going to do a Control-C and get out of my subscriber 1, and then we'll go ahead and publish channel 1, hello 3. And you'll see that subscriber 2 receives this information, but subscriber 1 did not. And so let's see. And then I'm going to restart my subscriber number 1 by getting my Redis CLI going again. And then I'm subscribed to channel 1. And then I'm going to do a publish to channel 1 again. Hello, world 4. And you'll see that subscriber 1 will get Hello World 4, but and so was subscriber 2. So what happened here was, if the subscriber is not listening at that moment in time, it's not going to receive that information ever. So that's the one downside to PubSub. But it's very efficient, very simple, very easy to implement. So there are certain use cases where this fits just perfectly well. Like maybe you've got an iPhone app that you want to let it know that you've got a new notification, or you want to have a notification go into a browser that says you got a message that just came through, and you want to change like the little circle from 1 to 2 or something. PubSub's great for that, because it's not the end of the world if you don't know the notification came in at that very second. All right, so you can go try this yourself, and of course there's lots of client libraries out there that will help you with this. And I think this is a great way if you want to build something quick and dirty for a hackathon, or if you want to build a simple system for your application to send fan-out notifications. All right, now let's talk about something a little bit more reliable, but a little bit more complex, and that would be Redis Streams. So very simple here. I'm just giving you I'm not going to get into a lot of detail today, because I just don't have the demo set up for this right now. But I do have a similar example that I'll share with you, so you can compare PubSub to Redis Streams. So first of all, you're going to do xadd and xread. So instead of doing publish and subscribe, you're going to use xadd and xread. That's the basics. Okay. Now let's see how this actually works. Oh, and what you want is you want to be able to communicate with your clients without missing data. So if for some reason a client goes offline, you want to be able to have that client come back online and then go and see what it missed. So it's not going to miss anything, because all of the notifications are they're not fire and forget like you would with PubSub. It's a fire. And by the way, if you weren't there, I am going to keep this information until you acknowledge that you've received it. So yeah, you want to make sure that your consumers can subscribe to topics independently and then notify the server independently that they've received them. And this enables a great event-driven architecture and asynchronous parallel processing. So this is a very popular trend these days. You've heard of Kafka probably, and Kafka has a very similar concept. It's very powerful and popular. But Kafka tends to be a little bit heavier. There's more software to install. And with Redis, it's very light and it's already built in, so you don't have to do anything more to use it. And so you'll have improved performance and reliability and scalability over something like PubSub. It avoids delays associated with periodic polling. So you don't want to constantly hit your server and say, hey, has anything changed? Hey, has anything changed? Hey, has anything changed? You're adding all this delay and latency and load to your server when nothing's changed. All right, so how does this work? So this again, you can set up this exact same demo the same way I did before. Start up your Redis server, just flush everything out so you don't have any bad data in there, and don't do this to your production servers. So then you're going to do xadd mystream1, and the asterisk basically tells the server to go ahead and create its own counter or its own unique key. It's actually an entry. So the key in this case is actually mystream1. And then you've got an entry that'll have a unique value that's basically a timestamp. And then you'd specify that your field called greeting is hello1. So hello1 gets sent. Now you'll notice now we're going to spin up my consumers, and we're going to say, and again, this is a very simple example. So you might end up doing something a little bit more sophisticated than this. But now I'm going to read, hey, give me 10 entries from a stream called mystream1, and start with 0. And it's going to, and you'll do that with consumer 2. Both of them will then receive that first hello1 greeting. Now, I'm going to cancel out of my connection to the mystream1 from consumer 1 by using Control-C. And then I'm going to go ahead and say xadd mystream1 asterisk and say, okay, greeting hello2. And if I then do from, let's see here, if I go back and start my CLI again, and I then have it running, I can then say xread. Well, then I'm going to go back over to xread count on consumer 2, and I'm going to say xread count 10 streams, my stream 1, 0, and it will see those. And then if I go back to, so we'll see that consumer 2 was actually able to read the hello 2. But then if I go back over to my producer and I say xadd my stream 1 asterisk greeting hello 3, go back down to consumer 1 and say, hey, I'm back online. Let me see what's there with my xread. It will then receive both hello 2 and hello 3. So it didn't miss anything. And of course, I can go back over to consumer 2 and do the same thing, and it will get all of them. So none, even though consumer 1 was down for a period of time, when it came back online, it could then go back to the producer and say, hey, what did I miss? Give me everything since the last time I asked. And you can set this up so that there's a blocking call so that it's just automatically streaming down, so you're not having to pull every time. And you can also acknowledge, I didn't do that here, but you can acknowledge to the server, hey, I've received this entry, so don't worry about saving it for me again in the future, because I've already got it. So Redis Streams is very powerful. This would be, we're starting to see Redis Streams being used in some of the popular frameworks. For example, I know that in the Symfony PHP framework, they now are using it. I think they've got this thing called messages, and you can choose the provider that you're going to store the persistent state of your messages in, and it'll send it out through Redis using Redis Streams. I think that's what it's called. And over in let's see, in the Java world, there is the oh gosh, what's it called? Spring Data Services, or Spring Data Redis, and Spring Data Redis can use Redis for use Redis Streams. And in the Node.js library, there's one called I'm blanking on what it's called right now, but it's called well, Hydra is one of them. So you can use Hydra, which has a nice microservices angle to it. So there's lots of libraries out there. Those are the three off the top of my head, but you can find libraries out there that are using Redis Streams. I think in let's see, yeah, I forgot the rest of them. I'll have to go and look those up again. So with Redis Streams, I would recommend that if you're doing intra-application communication from one component of your application to another, maybe either microservices, maybe they're just components of your application that you don't have normally talk to each other, but you want them to communicate, Redis Streams can be a great way to send notifications that something's changed and ingest data very quickly from something like Twitter. So check it out. Okay, so with that, here again are the 10 different data structures plus PubSub, and we did cover hashes and lists, hashes for sessions, lists for queues, sorted sets for the leaderboard or games or API messages, error messages, geospatial indexes. We didn't really get into strings much, but again, this is how you use it for a cache. Bitmaps are pretty cool. You can store ones and zeros there in a key, and this is very useful for things like you want to keep track of who's currently online right now. You don't have to run an SQL query to find out that, hey, I'm online right now. Who are the friends that I have that are currently online? You can store the unique values there. Each one of the ones and zeros in that bitmap are uniquely addressable. So you can simply pass in a list of friends, and it'll return back, here are the friends you have are currently online. And then you can use that with PubSub to quickly send out a notification down to the web page saying, hey, here's your list of friends. Here are the ones that are currently online, and this one just changed. So very powerful. Bitmaps, and also bit fields. It's an array of complex numbers. So instead of just ones and zeros, you can store larger numbers in there. This is great for ingesting metrics and things like that. Sets is great because let's say you just want to store a bunch of unique values with a key. So, for example, tags that have been associated with a blog post or a product that you want to have user-generated tags. or maybe a movie or something like that. Whatever you're storing, you can store these in a set, and it will ignore the duplicates. And it's very efficient, and so you don't have to like do an upsert. It just automatically just does like that upsert for you. And you might store tags or unique IP addresses for maybe some sort of cybersecurity application you're building. Hyperlog, I talked about this briefly earlier. It stores the probabilistic data. So, for example, you can say how many times does this word appear in this overall set of data, and it's very efficient. And then you can also store something like Redis Streams, we just talked about, where you can store and share event data, similar to how you might use Kafka. And then we got PubSub. So with that, we've pretty much covered the entry-level broad summary of data that you might use with Redis. There's so much more. So I highly recommend you just go look at the redis.io/commands webpage that is the website for open source Redis, and you can see all the different commands there. I'm showing you there's like close to 300 of them for these 10 data structures plus PubSub, plus a few other things like server clustering. You'll find lots there to inspire you. And then don't forget the modules that we talked about. That's another set of data that you might find very useful, or a set of capabilities that you might find very useful. Redis Search is very popular, and the others are gaining traction. I know Redis Graph will be coming out with version 2.0 fairly soon, and it's got a lot more capability. So, yeah, and I think we're going to have at the hackathon, there will be some folks from TensorWork who are the folks we partner with to create Redis AI, the module for storing TensorFlow and PyTorch models. So you'll get some help there if you're interested. And finally, one thing to note is Redis 6 is in the release candidate 1 is out. And so with release candidate 1, you have some new capabilities around specifically around ACLs. So if you wanted to build an application where users had limited access to certain keys, you can now build an application that manages user access to keys. And there's lots of different ways you can use this from storing secrets and all sorts of information, all sorts of different new capabilities that you can now use Redis for that previously you couldn't, because you couldn't limit who had access to keys. So a very simple example of this is you might say, hey, I want my administrative apps, and I want my my manager user profiles to be able to make changes to the data, but I don't want my users to be able to change the data. I just want them to have read-only, or maybe an API or certain types of users should only have read-only. And that way you can give out that user to the developers, and then they'll have just the access to the data that's appropriate for that user. So pretty cool. Lots of functionality in Redis 6. You should go check out the web blog from Salvatore on all the different things he's putting into Redis 6 release candidate 1. And I think it's probably going to come out. Redis 6 will probably come out in a couple months. All right. So with that, I think I'm done. Thank you very much. And we do have a couple questions. All right, cool. So what kind of questions we got, Drew?
Yeah, so from Benron, how to implement priority queuing?
Priority queuing, sure.
Yeah. And then also another question, he wants to show just the top N players.
Top N players, yeah. Yeah, so priority queuing, you mentioned, well, that could be interpreted a couple different ways. So let me think about this for a second. So a simple way to do priority queuing, and I'll have to apologize to you, because if priority queuing is a specific thing that you're talking about, I may not know exactly how that should be done. But a simple way that I mentioned in my talk was that if you want to have a queue called Q1, and you can do R push, or let's say L push, you can L push, L push, L push, L push, which put your items to the left of the queue, the left side of the queue, you can say rpush to push it to the right, which is going to put it right into the front of the queue, and that will obviously kind of put them to the front of the line. That's very similar to what you see in airports, or if you go to an amusement park and they have a special pass, like if you're a premium tier flyer, you get to go into the A queue and you don't have to wait as long. You just have to wait behind other A queue folks. But I think maybe what he's talking about is if the priority queue should have, you don't want to do rpush, 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 and over again, because you're putting the last person in the priority queue to the front of the queue. So the second and third people, if people keep coming, are going to just be cutting in front of your other priority queue members. In that case, you're going to end up probably doing a 2 queues. I'm guessing that might be the right way to approach this. And so you would then add, you'd like have queue general and queue priority, and you would always check if somebody's a priority item, you would put them into the priority queue. If not, you put them into the general queue, and then when you go to pull data, you would look to the priority queue first to pull the items out, and when there's nobody left in the priority queue, you would then go to the general queue to pull the items out. I'm guessing that might be how you do it. There's probably some client libraries out there like Sidekick, et cetera, that maybe they have this capability built in. So go check out Sidekick and Rescue. There's a bunch of them out there. What was the second question, though?
The second question is he wants to show just the top N players.
Yeah, top N. Okay, so that turns out I guess you're talking about the sorted set, like a leaderboard type scenario. Yeah. So there was a slide I had on this. Let's see if I can go back to it real quick. Okay, sorry. If you're looking at the screen right now, it's probably flashing through a bunch of slides. Here you go. So you'd use Z reverse range to get out the range of users. And I think this one right here, Z reverse range, game 1, 0, 0, I think that's going to pull out starting at position 0, which is your number 1 player. And then you would say, let's say I wanted 10, just my top 10, then I think that last number would be a 10. I think that's how it works. Excuse me. So I think that's going to do it for you. And if not, a quick search on Redis.io looking for the Z reverse range, Z rev range command will give you that answer. What else you got?
Great. So we have another question from Evan G. Excuse me if I said that wrong. How is the checkpoint handled in Redis PubSub?
Oh, good question. I don't know if I have the quite right answer for that one either. So checkpoint. I don't know if Redis PubSub does checkpoint. Maybe I can get some clarification from Majid or whoever that was. So with PubSub, it's fire and forget. So you're going to get the information from the publisher who's going to say, publish this information to a particular topic. So, for example, you might have said, okay, somebody might have subscribed to a topic on, let's say, RedisConf, and now when I go to publish to that topic called RedisConf, whatever I send to it is going to immediately get sent out to whoever subscribed to that topic. There's no information after that being saved. So I don't know what you would be checkpointing. With Streams, on the other hand, you have data that's stored at the server. And so your stream is going to be maintained on the server for as long as there are clients that have not received that information or up into a certain period of time. You'll have to read more about that to get the details on exactly how long that data will be stored there. And then I think the checkpoint usually means, okay, up until this point, the data is good. So I'm not sure how you do that with PubSub. That's all I got for you.
And another question from Atish. he missed your intro about the hackathon. Can you give a little more information about the hackathon?
Yeah. Oh, okay. So the hackathon, if you go to our website and look for the Redis Day Bangalore, you'll see the registration there with more details. It's about midway down the list of activities. There's or sessions. There's I think it's training first, and then the hackathon, and then Redis Day speakers. And the hackathon is it's a 2-day event, but for most people it will be a 1-day event. The second day is only for the 3 finalists that get chosen. So on that Tuesday, it's like 12 days from now. I think the 21st, January 21st. The hackathon will start in the morning and it'll go until the evening. And what we're looking for are any application you want to build, but we're specifically looking for event-driven, architecture-based applications. So Redis Streams, PubSub, queuing, these kind of things where something changes somewhere and then the notification gets shared with other applications or clients. We're also looking for people who are building applications with modules. So Redis Search, time series, Redis Graph, those kind of databases, Redis AI. And then if you want to build an integration with something, there's a lot of need for integrations with Redis. A lot of people are using Redis in a lot of different ways. So if you have an integration that you want to make, it could be with a bot. It could be with like a chat bot or something like that. Maybe one with working with Slack or something like that. Or an integration with another popular data type or data source or database. Or any other framework. So if you want to build a framework integration, and then just show on top of that, here's what would be possible if I built this integration. So, or if you want to use Redis 6 and there's something out there new that you want to show off, that would be great too. So lots of different ways you can demonstrate something new and interesting with Redis. Those are just a few. If you have any other ideas, you can reach out to me. I'm dave@redislabs.com. And then we have prizes. We have 3 prizes. I forget the exact amounts, but thousands of dollars in prizes. I think maybe a total of like $7,000 or $8,000. And then once we're having judging at the end of the day. We've got Johnny Karam. We've got as a judge. We've got Sripathi from Hashed-In as a judge. I think Iftak, our CTO, will be a judge. And we'll choose the finalists at the end of day 1. And then the finalists will give an extra day to continue working on their applications. And at the end of Redis Day, we're going to have a judging that will by the audience where we will choose the winners. So that's it. If you have any more questions, go check out the registration page and click on the link for the hackathon that says view more information.
Yeah, we have one final question from Sajal. It says, we are using heap sort and sorting dynamic scores in a multiplayer game example that you gave.
Cool. Heap sort. Okay, so I'm assuming that heap sort is some sort of library or component that allows you to do player scores in a game. I'm assuming that's what he means by that. I don't know what heap sort. I don't know if heap sort is a type of methodology or if it's a client library.
I think he's asking, are you using heap sort?
Oh, am I using heap sort? I don't know actually if that is how it's handled inside of the sorted set. I don't know if heap sort is. To be honest with you, folks, I should have mentioned this earlier. I am not the deepest technically capable developer anymore. I used to be pretty darn good at this stuff, but it's been a while. So I don't know how the internals of Redis is handling the sorted set to keep track of that. I don't know. Yeah, you can actually, a lot of times you can look up on Redis, Redis.io. Sometimes they talk about how he's doing it. On his blog posts, Salvatore's blog posts, sometimes he talks about how he's doing it. And also, not that you want to do this, but for some of you, the source code of Redis is actually very well commented and easy to read. So if you are into reading C code, I know there are people out there who actually do enjoy reading that code. So you can probably just see exactly how it's done. But I don't know the answer to your question. Okay. All right.
That's the last question.
That was the last question. All right, folks. Well, thanks for hanging with me here. Sorry I couldn't answer all of your questions. If you want to email me, I can get an exact answer to your question. Email me at dave@redislabs.com. And again, this was primarily focused on our hackathon, but we're planning to have more of these webinars as we go. So take a look at the redislabs.com/community website, where it's not up there yet, but we'll be having our updated schedule of both webinars and podcasts and our meetup events and other conferences that we'll be at, including, of course, our own Redis Conf, which will be in May. But we're really looking forward to seeing you at Redis Day and at the Redis Hackathon. If not, maybe the training. And if not there, then one of the meetups around India. And we'll look forward to seeing you in 10 days or 12 days. All right. Thanks very much.
Yep, and one last thing, thank you for joining, and this will be available on the on-demand. Thank you.
All right.